Hello, good morning. Today we're going to continue working on our Unit 6, Fraction Concepts and Operations. And our teaching point for today will be, I can find pairs of fractions that add to 1. That means that I will be taking a different fraction combination that when I put them together, they give me a sum equal to 1. So let's see. Today, Thursday, May 7, 2020. Our lesson for today is titled Fractions that add to 1. Alright? So keep in mind to write the date, lesson name, and teaching point just before you get to work on your quick practice. Today's activity are supposed to be uploaded to CISA, so keep that in mind. Alright? So let's jump in right away to our quick practice. In our quick practice for today, we have a word problem. Right? It says like this. Bella and Enrique are sharing pizza. That sounds yummy right now. Bella is hungry, so she says she will eat 1/4 of the pizza. Enrique says he's hungrier than Bella, so he will eat 1/8 of the pizza. Will Enrique eat more than Bella? Please explain. So I recommend that you pause the video and get to solve on your own. If you think that you got the answer, right here I share with you so you can confirm your answer. Anyway, let's see at one way that I could target this problem. Alright, I said no because if we take a look at the problem, so let's go back. She's saying that she will eat 1/4 of the pizza. And then he's saying that he will eat 1/8 of the pizza. So the question is, will Enrique eat more than Bella? Let's see. The answer is no. Why not? If I see that the denominator right here is greater than 4, 8 is greater than 4, why not? Right, so in fractions, the greater the denominator is, that means that the more pieces you will have. That means that you will have less of that something that you're cutting up. Take a look. So Enrique says he will eat 1/8 and Bella says she's eating 1/4. If you take a look at here, we're having the same shape, same size, we have the same circle. However, in the Bella's case, we only have 4 pieces. Since we only have 4 pieces, you can see that the area, the piece of every sector, let's say, is way bigger than the one in 1/8. In the case of Enrique, we have the same circle, but this time we have 8 different pieces. Since we have more cuttings, that means that the pieces will be smaller. So that's why we say, or that's why I say, no, Enrique will not eat more pizza than Bella. And that's why, because he's getting 1/8 and she's getting 1/4. And actually, you can see in a visual way right here that it is true. And if we take a closer look, we can actually see that Bella is having this quarter, for example, right here. But if you take a look, right here we have the same quarter, the same sector, but you can see that the amount that Enrique is eating is actually half of the one that Bella is trying. Take a look. Anyway, we're going to be taking a look at comparing fractions in further lessons, so don't worry about this right now. Alright, now I want you to think about pairs, alright, two numbers, of non-zero whole numbers. Whole numbers means that there are no fractions, not decimal either, that could correctly complete the equation. So basically we have 5 minutes. We have 4 different cases. So what we're going to do here is to look for two whole numbers that when we add them, these are equal to 5. So one possible combination that I could think of is 1 plus 4. 1 minute, that was a mistake actually there. 1 minute plus 4 minutes, then that would be equal to 5 minutes. Then we have 2 minutes plus 3 minutes, that's 5 minutes as well. Then we could try 3 plus 2, that is basically the same, and then we could try 4 plus 1. So right there, we have 4 different scenarios where we can combine two whole numbers and actually get 5 minutes. However, how does this relate to our teaching point for today? Let's see. Our teaching point for today, if we recall, is I can find pairs of fractions that add to 1. So we're going to be taking a look at different fractions, combinations, that when we add them, the result will be equal to 1. In our student activity book, and actually independent word for today, when we take a look, we will find something like this, where they will be describing a situation right after we're supposed to complete an exercise like this. So let's get to read this first. Fifth that add 1, fifth that add to 1. So every afternoon, students volunteers help the school librarian put return books back on the shelf, okay? The librarian puts the books in equal piles on a cart. So far, so good. One day, Jean and Maria found 5 equal piles on the return cart. 5 equal piles, keep that in mind. They knew there were different ways they could share the job of reshelving the books. They drew fraction bars, which is the way that we use to represent drawings of fraction problems. They drew fraction bars to help them find all the possibilities. First, this is the first exercise. On each fifth bar, we're saying fifth because we're dividing the fraction bar into 5 equal pieces. So on each fifth bar, circle 2 groups of fifth to show one way Jean and Maria could share the work. Each bar should show a different possibility. Then complete the equation next to each bar to show their share. So let's see. Alright, so right here we have the whole rack, let's say. So one whole is equal to all the books. We have one addend right here that will represent Jan's share. The second addend will represent Maria's share. This is our fraction bar right here, where we have 5/5, right? That is equal to 1. We actually have it right here represented. Now, what we're going to do is that we're going to circle different fraction combinations. And at the end, we'll see that those are equal to 1 because every fraction bar is equal to 1 right here. As you can see, 5 divided by 5 is 1. And we have the same cases at every time. Now, the first that I would try is 1/5 plus 4/5. Then I would try 2/5 plus 3/5. Why 2/5? Because right here I have 2 pieces of 1/5, so I have 2/5. On this one, I have 3 equal addends, and when I add them together, I will have 3/5, and then I'm keeping the same denominator. Then I could try the opposite, 3/5 plus 2/5, and then I would try 4/5 plus 1/5. If you take a look at the equation right here, you will see that they represent my selections. So right here, how many fifths do I have? I have only 1/5. However, here, when I add all these fractions, unit fractions, I will see that I have 4 of them. So that would be equal to 4/5. The same happens with 2/5, 3/5, 3/5 again in this case, 2/5 on this one, as you can see on the fraction. So basically, on your independent work, you're going to face a situation like this, and you're supposed to come up with the equations that are missing. Keep in mind that the first thing that you need to try is to circle the different addends. Then when you circle them, then you can come up and complete the equation. So in your independent work for today, you're going to have a second case that is pretty similar, but this time working with 6. Right? Then on your second part, you have a whole number, number 1. Right here, we have a fraction that represents 1. Whenever we have two quantities, let's say one quantity that is dividing by itself, it is to say the same number, every time that we have the denominator right here equal to denominator on top being divided by themselves, then we will always have 1. So right here, what they're doing is breaking apart this fraction right here. So we're coming from the whole number, then representing that whole number with a fraction, and then we're breaking apart that fraction in a unit 1 combination. All right? So since we already have 1/7, and we're supposed to have 1 whole, how many sevenths are we missing to complete the 1? So since I took away from here, then that means that I need 6 more to actually reach the 7 that I have on top. Keep in mind that we're having the same denominator, the common denominator, so that means that the only thing that I need to work on, or the only thing that I will have different, is the numerator, the number on top. So you will try the same for the remaining exercises. If you try for number 8, let's say 8 divided by 8, right here I can see that they broke apart 3 8. So what am I missing to get to 8 out of 8? I'm keeping the same denominator, and I would add a 5 on top. So the missing fraction would be 5 8. And so on, you will complete the remaining ones. That will do it for today, guys. I hope that you have enjoyed this lesson. If you have any questions, just let me know, and we'll get to a solution. It was a pleasure again, and see you next time. Bye-bye.